Hello everybody, my name is Barney Lawrence, and for the next 20 minutes I'm going to be explaining DAX through the medium of dance. I hope you enjoy the session. First of all, a little bit about my credentials. Most important to know is that I'm a dancer. I've been trained, and not only that, I've performed on stage in front of audiences a number of times. Here's a picture of me at my last show. Impressive. Work-wise, I'm currently a senior business intelligence developer for Jet2. Before that, I led the business intelligence team for an NHS trust, which is where our story begins. Back last year, in March, the organisation I was working for the NHS had decided to take the plunge into Power BI and start building reports. As part of us, to get us ready to go to sort out the training, I came along to SQL Bits, as did some of our analytical team managers, to go through 2 days of training days with Marco Russo and Alberto Ferrari, so we could get on top of the DAX and pass it on to the rest of the team. By the end of the 2 days, I was looking a bit like this. I'm the theory, I'm the technical guy. I was pretty much getting it and thinking, we're getting there. Analytical team members were feeling a bit more uncertain, but could see where we're going. Then we realised we needed to teach the analysts, and we looked a bit like this. As a result, I came up with some ideas, some ways of presenting some of the key concepts, some of the hurdles towards understanding DAX that I could share with other members of the department that would hopefully give them a way of visualizing what was going on and hopefully be a little bit more memorable than throwing a textbook at them. And as I feel they're useful, I thought I'd share them all with you today. What are we going to look at? We're going to look at 3 things. Filter context. What collection of items go into our measure? Row context. If we want to do something more complicated and iterate through the objects in the filter context, we get a row context. Finally, calculate and context transition. What happens if we want to create an interaction between those two beyond what is already there in the basics? Let's start really simply. Here we have a measure. It sums my values. It looks a lot like something you would see in Excel or in SQL. It is, however, a little bit different. In Excel, you would write your formula and you would point at what you want to sum. In SQL, you'd write your aggregate query, you'd specify your group by, you already know up front exactly what you're grouping and what you're summing. With DAX, we write our measure before we know what it's going to operate on. It's one of the sources of power within it. It means we can write one sum and we can use it over and over again in multiple scenarios. But what defines that set of values? What defines it is all the items within the filter context. And what does a filter context look like? Well, to me, a filter context looks a lot like a dance. Here we have a dance. And we've got some filters on it. We've got people who turned up to the dance. But within there, we have more. If we look closely, you can see we've got band up here, and then we've got individuals in a lot of groups. Each of those potentially is a different filter context. Imagine we have a bar chart showing year by year values. One bar is 2016, that's one filter context. One is 2017, that's another filter context. But our measure, building that bar chart, applies to each one, taking each filter context, giving us a different result to build them all up into our one chart. Here's a simple data set. We can do our simple calculations. We've got a filter context. Here's our dancers. Maybe we sum up value 1. But what if we want to do something a bit more complicated? What if we want to instead multiply value 1 by value 2 and then add them all together? We might be tempted to write something like this. Sum of value 1 by value 2. And what answer do we get? We get an error, because sum only operates within the filter context. It's not one value 1, it's not one value 2, it's all of them. There is no order, there's no process of stepping through those values as far as sum is concerned, so it doesn't know how to pair those two up. What can we do instead? We need a different formula. Maybe we'll try this one. The sum of value 1 times the sum of value 2. Now we've only got one value inside each of those expressions. It should work. How does it calculate? It does what you've asked it to. We add all the value 1s, we add all the value 2s, then we multiply them, which gives us 18, which is, again, not what we want. Time to try something different. And what we're going to use is SUMX. The X on the end tells us that this is an iterator. Iterators are different in that they iterate. We give them a table, we give them an expression to evaluate, and what happens is the iterator iterates through every row within the filtered context, carries out that expression, and then finally, when it's done that, then it does our sum to add them all together. What does that look like? Well, to me, it looks like a bit like a dance. Here we've got another dance. It's similar to the last one, but we've got a bit more structure. If we look up ahead, we can see some people have formed an arch, and all the other couples move through one by one through that arch. And that's what our iterator is doing. When the music starts, first couple goes through. We evaluate that expression within the context of that row, the row context. Then the next couple, then the next couple. Let's follow that through from an overhead perspective. Here we have our dancers, ready to go. Music starts. First pair go round, and we get our 2 times 1. Next couple go round. We get another. Last couple. One more. Now we've evaluated every single row. We can add them up and we get 6, which was the answer we wanted, which is great. Some point we might try something like this. It's virtually the same calculation we used before. The only difference is I've wrapped the 2 values in a sum. What's going to happen? Maybe we get 6 because we're iterating through those rows. And on that row, there's only one value 1, there's only one value 2. Sum of one value is that value. It's not 6. Perhaps it's 18, because we've already seen what sum of value 1 times sum of value 2 is. Perhaps it doesn't pay any attention to the iteration at all. It's not 18. In fact, we get 54. We get immensely confused, and we're tempted to go back to Excel where everything makes sense. But we're not going to do that. We're going to explain exactly what's happening, why it's happening, and that will help us understand exactly what's going on with our iterator, with our row context, and with our filter context. So we're going to perform the same dance again, but in a slightly different environment. It's a cold, wet night in an East Midlands leisure centre. Our dancers are a little different too. They're smaller, younger, and they're sporting tutus of which they are very, very proud. This is my daughter's dance class. There are lots of them. We get ready to dance. They line up like they did before. The problem is, a 5-year-old in a dance class does not fully grasp what's happening. They are very aware of their filter context. They're here in a tutu, in a dance class, ready to dance. They know that. But as we iterate through, just like our sum that we've seen within our iterator, we're less aware of the row context, specifically what's supposed to be happening at any one time. In fact, our sum only cares about the filter context. Our dancers only care about the filter context. And so this is what happens. Our iterator hits the first row. We're ready to dance. And what happens? Everybody dances. They all go. They don't care about the row context at all. Which means we get 3 2s, 3 1s, and we're up to 18. But the music is going to carry on. Our iterator is still going to iterate. Which means we hit row 2. And round they go again. Which gives us another set. Takes us to 36. Final round of the iterator. You can probably guess what's going to happen. Everyone goes through. We hit another 18, which takes us to 54. At this point, the parents are a little bit embarrassed, and the dance teacher is questioning some of their career choices. So what can we do to fix this? Obviously, we could go back to the first version of the measure, which is the right answer, but we're going to find another way of fixing it so we understand a little bit more about DAX. Now, how would we fix the dance? We would need to do something to get those little dancers aware of not just the filter context, but also what's happening on in the row. Who could possibly be influential enough to get their child to listen to what's going on? And the answer is, of course, the parents. The second time we do the dance, the parents start calling out, telling their child when they should go, when they shouldn't go. They push that row context into their child's filter context, and they listen, and we get the right dance. DAX doesn't have parents to help us out, but it has something that carries out a similar row, a similar function. It has calculate. And when we put calculate into an iterator like this, we get context transition. Calculate will look at all the values on that row, in that row context, turn them into filters and push them into the filter context. And now, every step of the iterator, we have a different filter in the filter context, which means we get a different result. And that brings us back to where we want to. Every row is unique, and we're all happy. Unless it's not. Let's break it once more, just so we're clear on exactly what's happening. Here we have a very similar data set. The only difference is today in the dance class, we've got 2 Olivias. Same name, same dress. Functionally, they look identical. How does the dance work? Well, here's our Olivias. Here's our Amelia. Amelia has turned up dressed as Spider-Man today. Why? Because she's 5 and she can, and her parents have very wisely learnt to choose their battles. So the dance begins and it's Olivia's turn. Olivia goes, and so does Olivia. Which means we get both of them added, both of them multiplied. Next up, it's Amelia's turn. Amelia is unique, so she goes round on her own. And we get the 2 times 1 like we want to. We've still got one more iteration though, and it's Olivia again. Both go round, both get added in, and we're taken to 18. And the reason why that is happening is because there's a limit on what calculate can do. It's not actually making each row unique. It's simply taking everything it knows about those rows, gathering them up and adding them into the filter context. If there is nothing that it can add into that filter context to make the rows unique, then we still get that duplication. There's nothing we can do on our measure to fix this. If we want to resolve the problem, then we simply have to make the data unique. We need to add in Olivia's surname, hopefully it's different, or a date of birth, or just a row number. That's all we've got time for. So let's just quickly look, what have we looked at? We looked at the filter context. The filter context defines a set of rows from our data set that are going to be operated on by our measure. We've looked at row context. If we iterate, if we're using an iterator, then we step through each of the rows one by one, evaluating the expression, and that expression is evaluated within the row context. The row context does not change the filter context. The filter context is static. Just as when we look at the filter context, there's no order. If we want to link the two, we can use calculate to create context transition. And at that point, we bundle up everything we know about the specific row in the row context, push it into the filter context, and then our filter context can be different for every single row. That's all I have to share for today. Thank you very much for listening. I hope this is useful, and I hope you can take something away and make your measures dance.